Welcome to the first tutorial video from FTC Team 14596 Accelerate. This is a new thing we're starting to help newer FTC teams learn the basics of all aspects of FTC, whether that's programming, building, outreach. In this video, we're going to be going over a basic TeleOp program and how to go about making one, what all the parts in one do, how they work, and we will be going through that, explaining it on the way, and we hope that this video is useful for other FTC teams, no matter how experienced you are in FTC or not. So the first thing you're going to do is head over to OnBot Java. You can find the link to your OnBot Java on your phone in the driver station app, which connects to the robot. And so once you're in OnBot Java, to make the program, if you don't know how to do that, you're going to go to this plus sign up here, that's add file. You're going to insert a file name. For this video, we're just going to call it tutorial. Maybe not. There we go. And then put this into a folder. And so for this video, we are making a TeleOp program. So we're just going to select this TeleOp button on here. It's not necessary. It just gets a little bit extra code we might need to write out of the way. So you hit OK, and then your new file you made is going to be down here. So now you have the tutorial file. So the first thing that we are going to do is actually just give the file a name. This is just what is going to show up on the phone. So we're going to call it tutorial. So we name the file. And so this name is just whatever's going to show up on the phone when you go to run the program. It just makes it easy to find. And the next thing we're going to do before we get down to the code is in this public class tutorial line, our tutorial is going to be replaced with whatever you name the file. All we're going to do is just say extends op mode. And so what this extends op mode does is that we're making a class called tutorial, which is going to be run by the robot. And so this extends op mode is another class that's already been made for us in this which is what we're importing up here. We're importing the op mode class, so we're just extending our class to that. So then we have access to all of the functions, variables, methods, everything in the op mode class. So we don't have to remake those because they're already made for us. So we're just using those. So now that we're getting into the actual code, first thing off, we need to create two methods. The first one we're going to make is a init method, and this is going to be whatever you put in the init method is what is going to be run when you initialize the program, or you click on the run button the first time. And then we're going to make one more method function, whatever, and it's going to be a loop. And so whatever you put in here is going to be ran when you actually run the program or you press the button the second time on the phone. And so you can think of this as a while loop. It will constantly just loop through, that's why it's called loop, and just keep running it until the program is stopped. So now we have a few variables that we're going to need to define first. So the first variables are going to be DC motor variables. And so what these variables are is these are going to be our motor variables. So we're going to assign each, we're going to have 4 variables here, and it's going to be assigned to a specific motor on the robot. So the variables in our case, I mean, you can name these whatever you want. For this video, we're going to make it simple. We're going to do front left, back left, front right, and back right. with a semicolon at the end. So the DC motor data type just tells the program that these are motor variables. They're not strings or integers or doubles or floats or whatever that. The DC motor is a data type made. It's a special data type made that we don't have to make, but that lets the program know that they are in fact motors. And so the next variables that we're going to find are going to be they're going to be speed variables. So they're just going to be we're going to use those to figure out the speed that we want each motor to go to, and then just assign that motor's power to the speed variable. So we're going to make these variables doubles, and so the reason we make them doubles is because we're using the joysticks to drive. Those are a -1 to 1 with decimal points in between. So if let's say we made this an integer for example, we would either get the motors to not run at all, or run at full power, or 0 to 1, since integers do not allow decimal point. So we use a double here because it it allows representation of floating point numbers, which allow decimal points, and it's 8 bytes to store the variable. For example, floats are 4 bytes. This just allows a lot more precision when you're defining the variables for speed. So the variables we're going to have here are, we're going to do front left speed, or FL speed. I mean, again, you can name these whatever you want. We're just going to keep them simple. So FL speed for front left, BL for back left, front right, or front FR for front right, and BR for back right. Very simple. So that is all the variables we need actually. So we're good. So now in the init, our motor variables up here, the program knows that they are motor variables, but they don't actually know which motor they are for. So what we have to do is we have to define what motor those variables are for. So what we're going to do is we're going to use the hardware map, which is essentially the configuration in the phone. And so we're just going to say .get, so we want to get something from that hardware map. And so in the parentheses, we're going to say DC motor.class. So we want to say we want to get a DC motor or a motor from the configuration on the phone. And then here we're going to put the name. So we're going to say front left, and this is just the name of the motor that's in the phone. Again, you might name yours FR or FL or whatever. This is just the whatever is the motor is named in the phone, and then you're just going to do the same thing for all 4 motors. Alright, so now that we have all of the motor variables actually assigned to specific motors, we were able to control those variables, like give them power or whatever, and that will control the actual motor on the robot when the program is run. So the next thing that we want to do is I guess the next thing is fully dependent on how you have your motor set up on your robot. In our case, and in other people's cases, you might have 2 motors that are reversed in the direction than other motors. You might have all 4. So the way you fix this, so you don't have to do it later on in the code with negatives and positives, is there is a set direction method. So you can do the front left or whatever motor dot set direction. This will set the direction of whatever it is. So if you want it to go reverse, what you do is you do DC motor simple. This is a different class, and then DC motor, and then all you do is say dot direction. And in our case, we want the front left motor to be reversed. And then, so again, this is different for everybody. It just depends fully on how you have your motors set up on your robot or not. Actually, we want our front right motor, my bad. Again, set direction, DC motor simple, it's a different class than DC motor class. So the final thing that we have to do in the init is fully optional. It depends on how you want your robot to drive, and that is the zero power behavior. So what the zero power behavior is what is the motor going to do if it's running and then you give it zero power. There are two options. You can either have the motor stop, or you can have it coast and slowly go down to zero. I know for us and for a lot of teams, have the motor stop. So what we do is we just do front. We get the motor, and then you say set zero power behavior. And then if you saw the autocomplete, it's a DC motor dot zero power behavior. And then you put another dot, and this is power behavior. You can either brake if you want the motors to just stop, or you can do float, which will have them slowly coast down to zero. So we're gonna do brake, and then you're good. Once again, you're just gonna set the zero power behavior for all the motors that you want change the zero power behavior to. Alright, so we have all of our motor zero power behavior set. So now we are done with the init function, or init method. So now we're going to move down into the loop. So this is what is actually going to run when the program itself is running. So the only things that we need down here is to assign our speed variables to a number based on joystick inputs, and then assign that variable to the power of the motor. So what we need to do to assign the variables to their power is we need gamepad inputs. So you do gamepad 1 or you can do gamepad 2 depending on which gamepad you actually want to drive. We use gamepad 1, and then for joystick driving, all you need to do is do dot depending on which joystick you want to actually have move the robot, and which one you want to have turn the robot for making them drive. We are going to use so we're going to use the left joystick. So you do dot left underscore stick, and then we're going to do Y first, and this is going to be the up and down motion, like forward and backwards movement of the robot based on up or down movement of the left joystick. So then, from that, for the front left wheel, we're going to subtract gamepad 1 dot left underscore stick underscore X. So what this is the X is a left to right movement, which corresponds to a left and right movement of the robot, essentially. And just having these two in there, we now have full control of the robot. Any direction you move the left joystick, the robot will move in that direction once we get all the other motors on there. So what we're going to do is get the back left speed, once again, as left underscore stick underscore Y, and then however, this time we are going to add the stick X, and this is because the way Magnum wheels are positioned to run and how they actually move the robot itself. Can't have them uniform for everything. They're actually because they face inwards. So now we're going to do the front right speed, and this is going to be the exact same thing as the back left speed. So you can think of it as diagonals are the same, but across and up and down are not the same. This is left stick Y. I'm going to add gamepad 1 dot left underscore stick X. And then finally, back left, once again, it is the same thing, or back right, my bad. It's the exact same thing as the front left. Diagonals are the same. Alright, so we have the movements of the robot, and that's great. But what if you wanted to turn? Obviously, turning is a very key functionality of anything. So the way the turning will work is it will rotate the robot around the center of it, or origin. And so what we do is we use the right joystick for turning. If you move the right joystick to the left, the robot will turn in a counterclockwise direction around the center. If you move the right joystick to the right, then the robot will turn in a clockwise direction around the center. So for the front left motor, what we're going to do is we're going to subtract gamepad 1 dot right underscore stick underscore x, and this is the left right movement of the right joystick. And we're going to do the exact same thing for the back left, which is a subtracting of the right stick x, and then it's going to be opposite for the two right motors, where we add the gamepad 1 dot right stick x. And it's probably a good time to mention that these pluses and minuses will entirely depend on how you have your motor set up in your robot, and so it will probably not work at the same if you run exactly this code. So you're gonna have to play around with the pluses and minuses a little bit, and the best way to do that is if you move the, let's say you want to turn and the turning is opposite than the what's expected. All you do is turn these pluses into turn these pluses into minuses, and these minuses into pluses, and then that will reverse the turning to work. And it's the same thing for the forward, backwards, left, right movements of the robot. So now that we have the variables defined, the final step is to simply, let's just move this out of the way a bit. The final step is to just assign the powers of the motors. And that is simple to do. It's just, you get your motor, so in our case, we're going to say front left, and you're just going to say dot set power. And then in parentheses, you're just going to put the power. So if you just want to run motor at constant speed, you can do like 1, -1, 0.32, anywhere between -1 and 1. But we have our variables, so we're just going to set this power to our front left speed variable. And then you can do that for all of the motors. Alright, and there we go. All the motors have their power set. And so we're just going to hit the build everything button in the bottom right. And I just forgot E right there. Ignore that. And so, as you can see, it's built successful. There are no errors. And so, this program will show up on the phone under the name tutorial, which is what we defined up here, in TeleOp parentheses name equals. So that's basically it to a TeleOp program. Once again, this is the first video, a tutorial video we've done. We plan to release more in the future. We're going to have more programming videos like on autonomous, that sort of stuff. We're going to have building videos that help out, and have videos on outreach, sponsorships, judging, all of that basic stuff that will help newer FTC teams and even some older FTC teams just prepare themselves for competitions that might be coming up in the near future. So, thank you all for watching, and just stay tuned for those upcoming videos.